Today we're going to be doing an introduction to applied behavior analysis. I'm just going to be going over kind of brief touching different areas of the science, and then we'll do questions at the end. So, who am I? Um, so my name is Stefan Yunanulu. Um, just my background, I graduated with a bachelor's degree in psychology. And after I graduated, I didn't really know what I wanted to do. A lot of my training or education in undergrad was really geared towards getting towards a PhD, but I really didn't feel like I had done well enough to be like a competitive PhD applicant. And so I didn't really know what I wanted to do. And I'm applying for jobs, and I randomly got a job in a group home for individuals with developmental disabilities and severe behaviors. And I worked under the supervision of a behavior analyst. And it was really amazing, even with really rudimentary, basic, like barely any education in behavior analysis. I was really able to teach some of these clients some pretty cool skills. I taught a guy, how to make his bed. Taught another guy how to I'm sorry, I'm a little stuffy. How to use a radio by himself instead of having to come get us to do it for him. Um, Taught another guy. So what he was doing was he was like rubbing his butt on people. So, we did a behavioral treatment. We got that to stop. Just seeing the changes we made in these guys' lives. And these were all adults, and many of these people had problems that had gone on for literally decades. So it was a pretty cool experience to, in a small part, enact those changes. Um, that really spurred me to go to graduate school for my master's degree. I did that for 2 years, really a year and a half. And then towards the end of my master's degree, I needed to start my clinical internship. They weren't able to provide that at my the group home, so I switched to working in pediatric autism. Um, I worked at an in-home setting. I worked in a school. Um, and then when I finally did get my BCBA, I worked in a pediatric clinic for about 5 years. So I did that, doing early intensive behavioral intervention, which we'll talk about what that is a little later. Um, and really across the lifespan, across young childhood, mostly working with kids ages 2 to 6, a couple older kids, maybe like elementary school, and then a few middle school, high school, and even one gentleman who was in college age. Um, I did that for a while, and then I decided I wanted to switch. I worked in a special education co-op, so that was like a school, and that school was basically 100% individuals with developmental disabilities of some sort. So I worked there as a behavior interventionist, a behavior specialist. I did that for a year. I decided I didn't really like it. The schools, they didn't pay me very much. Um, and then I got my current job. So right now I work with adults in a crisis stabilization unit. So what we'll do is we'll get individuals all sorts of diagnosis of all sorts of different problems. They'll come to our program for 3 months, and our goal is to try and to reduce and stabilize their behaviors as much as possible. And we really see the gamut from severe self-injury, severe physical aggression, to things like pica, which if you don't know what that is like the compulsive eating of non-food objects, working with sexually aberrant behaviors. I work with some clients who were pedophiles, I guess, and working on like behavioral treatments to try and help with that. Um, I mean, if you could name it, I've probably worked with it at this point. So quite a bit of experience in this field. Um, I'm super happy to be here and to share some of my knowledge with you guys. So just some terminology to kind of get us oriented. When I talk about behaviorism, I'm talking about the philosophy of science that underlies both applied behavior analysis and the experimental analysis of behavior. And I'll be kind of going back and forth between these two things. So what is the experimental analysis of behavior? So that is more like really the basic science part of behavioral sciences. So that's manipulation of behavior in laboratory settings to produce basic science and search for universal principles in behavior. These are people who are not always, but most of the time they're working with animals. They're working in highly controlled environments, and they're very systematically manipulating variables to try and find patterns Um, we'll talk about this a little bit more, especially when we get in the history section. Um, and then we have applied behavior analysis. So the principles and the work that is derived from the experimental world is then kind of translated into practical technologies of behavior. We'll talk about what that means as well. Um, okay, so just to keep that in our back pocket. So what is ABA? Like we just kind of mentioned it. It is definition would be uh, is the application of principles of behavior to humans, and that's a big thing, especially to humans for socially significant ends. Um, we have the seven dimensions of ABA. These are kind of like what defines the field and how you can decide if something is ABA versus something it isn't. Just like we'll talk about it a little bit more in the history section, um, but what we would call ABA today, maybe 50, 60 years ago, would have been called behavior modification. And there, a lot of these movements from ABA or from behavior modification to ABA were kind of derived from these seven dimensions. And the first dimension is that ABA is behavioral. And what that means is that we are fundamentally concerned with behavior of the organism. We're looking for something the organism is doing. Um, that's what we're concerned about. We're not necessarily concerned about things like information processing or perception or whatever, or potentially biological processes. And not to say those are unimportant or are not worthy of study, but then they would perhaps fall outside of what we would consider relevant to ABA. Something that's applied. So when we talk about applied, what we're really talking about is something that is uh, useful for the learner or for whoever our client is. Now, you notice here I use the word socially significant. You know, what that means is always going to depend a little bit on one, the society and the context we're in, and two, what the individual wants. You know, for example, when I'm working with my clients in severe behavior, it would not be a socially significant behavior to teach them how to do backflips, right? That probably wouldn't help them at all. It could be something we could do using, technologies of behavior change, but I don't think that would help them. But if, let's say I was working as a gymnastics coach or like in a sports-based behavior analysis program, which do exist, and we'll talk about that later. Um, then teaching backflips is super socially significant, right? So, what the applied dimension is really challenging us to do is to think when we're selecting behaviors to teach our clients or whatever we're working for them, what is useful to them fundamentally? What is going to improve their lives? Um, Technological. So in ABA, when we talk about technologies of behavior change, what we really mean is thinking of procedures that are reliably able to produce different behavior changes we want. And a good analog is, this is a biology server. When we talk about medicine, like if you take a pill or a drug, you're kind of expecting that that drug is going to do something. Now, again, biology is complicated. It might only have like a 70, 80, 90% chance, but more often than not, we're deriving principles of biology to medicine and then we're developing a treatment, right? It's really the same thing with behavior analysis. That's the goal, is that we want to create systems of behavior change that can, as reliably as possible, produce behavioral outcomes that are useful to all of us. And if you think of that, that's a really profound kind of idea. Um, a lot of our problems in society are fundamentally behavioral if you think about it. Things like we just went through a global pandemic. Imagine a world where if we had a technology behavior change to encourage people to, for example, wash their hands regularly or wear masks, right? Um, or even more basic, working on technologies of behavior change to help people lose weight, for example, or to help stop smoking. Um, to some degree, technologies derived from other sciences, so for example, biology, can kind of overcome that, but it can be difficult because sometimes, again, the problem isn't fundamentally like a problem of like a drug or whatever. It's a problem of behavior, right? So that's where the technological aspect comes in. Um, Being conceptually systematic. When we talk about behavior analysis, we really try and focus on remaining true to the science. or really speaking in terms of concepts that have really strong foundations. Um, Corollary to this is that what really defines behavior analysis is a kind of like a strong ideological bend that we really do focus on some very specific philosophical and scientific commitments, which is a little different from maybe more traditional psychology, where it's more theory theory driven. Where a lot of parts of psychology they'll kind of come with a theory and from that look for evidence. Behavior analysis is backwards really, where we'll gather a lot of data, especially when we're talking about the experimental analysis of behavior part, and um, and from those data derive principles. Um, Analytic. We're going to talk a lot about single case research design, but fundamentally, when we talk about behavior analysis, there is an analysis part that ideally there should be a feedback loop of whatever results you get clinically are going back into your treatment planning and that you are making changes in a fluid and rapid way. Behavior change in real life is hard. It, we often don't have a lot of control over a lot of the variables that are going on with our clients in their lives. And so it really behooves us to be able to make rapid clinical decisions, that are based in reality. Especially when we're talking about the kind of problems we deal with, which are often like things like physical aggression, things like self-injury. What I often find is that people will overreact. They'll like something maybe bad will happen and they want to make big changes, right? When when we look at data, we see, well, actually, well, it's true that we had a bad day. We actually see that our client from the data has actually been doing a lot better, that we've been on a trend. And so it might not be the case that a big change is warranted. Likewise, we might say, oh, this treatment is working, when in reality it's not. It is a common cognitive bias, I guess, that we have where a lot of times we will think that any treatment will be doing something, and this is how a lot of like pseudoscience proliferates. Behavior analysis really challenges us to kind of have data, have evidence to back up that our treatments are doing anything. So generalizable, super important. It's great if you get a really good clinic, or excuse me, a really good treatment that's working in your clinic or working in the school. But if it's not generalizing across client settings, it's not really helping them at all. A really great example is like toileting. And I've had this happen to me, for example, where I've had a child with autism toilet trained in the clinic, and then they go home and they're having accidents constantly, right? So in reality, it's not really helping the individual. We really want to make sure that whatever behavior change we do is able to go across different settings, that it's stable and that it's lasting, right? And the very last thing is that it's effective. This kind of gets into the analytic part, but whatever we're doing, we want to make sure that we are actually doing what we say we're doing, that the treatments we're providing actually are causing some sort of tangible change in behavior. Um, it again, behavior change is hard, and a lot of times things will fail, and that's okay in the sense that as long as you keep making changes and you do eventually find something that'll work. We'll talk about that a little bit more, especially when we get to the section on single case research design, and I'll give you kind of real life examples of what that process looks like. All right. Um, Additionally, ABA is kind of defined by its use of, as I've been alluding to, single case research design. That's kind of a defining aspect of the science. High levels of clinical data collection. In other fields of psychology, they really don't collect as much data. Um, I know, like in some parts of mental health, they'll do like SUDS, so subjective units of distress, but that might be like a survey they take like once in a while. With ABA, we're really collecting moment by moment data on our clients and using that to um, make clinical decisions, that analytic component that I mentioned. ABA treatments are really flexible and creative. What's really great about ABA, I think, is that it really is a lot of detective work and it really challenges you to figure out different potential um, avenues of treatment. You know, um, especially with our population, with people with developmental disability, you might kind of do all sorts of wacky, crazy things that might be indicated by data. A really great example is, for example, when I was a intern, I was working with this young man, and we were working on teaching him like independent life skills. And this dude was super motivated by Power Ranger role plays. So what we ended up doing, yeah, we ended up doing is like conditioning Power Ranger role plays on the completion of a lot of his task lists or a lot of the skills we were teaching him. And it was actually incredible. This guy was so motivated by this that we really saw like a disappearance of a lot of the negative behavior he was doing around completing like activities of daily living and um around uh, around like being educated or being taught at all. And now he would like literally I would come into the house because we were doing a home-based treatment, and he would say, "Oh, Mr. Steven, look what I did," and he'd show me his list, and we'd check everything. He'd do everything, right? It's a pretty creative thing, right? So, and then we would role play as Red Ranger. No, I was always the Blue Ranger and he was always the Red Ranger. But regardless, we would do that. You know what I mean? And it's that kind of like creative problem solving thing that we're always trying to do to really address some of these really difficult problems that sometimes can really seem intractable. Um, and then, as I said earlier, when we talk about the behavioral aspect, we are focusing primarily on behavior outcomes, and that behavior of some sort is the data by which progress is measured, whether that's number of times a client makes a request, whether that's number of times they wash their hands, whether that's the duration of books they read or pages read. Whatever it is, we're looking at some sort of physical behavior, and that is what's relevant to us, right? We're not, and that can be pretty encompassing. We'll talk about that again a little later, but that's primarily what we're looking at. When we talk about data, we're talking about actually measuring things our learners are doing. Okay, so I want to go over a brief kind of history of behaviorism, and talk about some big names, and has the science developed. Um, So I wouldn't call Thorn. So we have Edward Thorndike. I wouldn't call him a behaviorist per se, but he laid a lot of the foundations that would kind of evolve into behavior analysis. The big one is what he called the law of effect. That responses that produce a satisfying effect in a particular situation become really basic stuff. Um, I we don't really learn too much about Thorndike in behavior analysis, but I do just want to mention him because the roots of the field go way back. I believe he was active in the 1860s and 70s. And now we probably all know Dr. Pavlov. So Ivan Pavlov, um, he discovered respondent conditioning. Many of you, if you've taken an introduction um, to psychology class, probably have learned this as classical conditioning. I don't actually know why in behavior analysis we refer to it as respondent, and then psychology they say classical. Regardless, he discovered that. But what more importantly he did was he really demonstrated the basic science aspect of behavior analysis, that you could take behavior and you could control it under strict laboratory conditions, right? um, Additionally, respondent conditioning is really important for a lot of our behavior, and a lot of aspects of psychology. I'd even say it's one of the bedrocks of psychology along with operant conditioning. um, and he really did serve as a model and inspiration for some of our later thinkers, including Dr. Skinner. All right, so super important. Um, he really kind of maybe laid a little bit more of the formal groundworks. And then we have, I would say, one of the big fathers of behaviorism is John Watson. So John Watson wrote really the Behaviorist Manifesto, the psychology as the behaviorist sees it. A lot of the things that I talked about earlier, he really laid out the idea that psychology should be a natural science, that psychology should not be interested in any sort of internal thoughts or internal processes, that it should fundamentally be interested in behavior itself. Um, he rejected completely a lot of pre-scientific ideas that psychology was really operating on, with introspection. A lot of these things that today we even take as pseudoscience, but he really laid the foundation that they are just not acceptable if psychology is to call itself a science. Um, the idea of behavior analysis primarily as a natural science, not a social science, which is a big aspect of a lot of the science now. Like when I talk about technologies of behavior from the previous slide, those are like, when we talk about technologies, they are things um, derived from excuse me, like basic laws of physics, basic laws of biology, right? Likewise, we want the same with behavior. Um, he also founded what's called methodological behaviorism. So behaviorism has many different philosophical schools. Methodological behaviorism is maybe what a lot of people think about when they talk about behaviorism. That is, you completely ignore any sort of internal variable. You're only concerned with outside variables, variables outside the skin, and like you kind of deny the existence of like cognition or whatever. Um, Interestingly enough, methodological behaviorism is kind of the foundation of cognitive psychology. That's another topic, but it is a little irony of history where Watson was so against any sort of internal like research or consideration, and then his science, his idea kind of graduated to cognitive psychology. So fascinating how history turns out. And we have our boy Buford or Burris Frederick Skinner. I think his friends, I've met a lot of people who knew him, and he went by Fred Skinner. But B.F. Skinner um, discovered operant conditioning, which is probably the biggest, most groundbreaking discovery, I think, in psychology to date in all of human history. He formally started the experimental analysis of behavior, um, like as a science. I believe he started SAM, so that this scientific examination of behavior, that journal. Um, he discovered schedules of reinforcement. Again, another massive discovery for psychology. He created verbal behavior, which is a kind of the conceptual analysis of how we speak or why we would engage in different verbal behaviors. And then he also founded radical behaviorism. So radical behaviorism is this idea that there are internal processes, but those internal processes are subject to the same operant forces as external behavior. So if you think certain thoughts, those are beholden to various aspects in the environment. And then I think that idea also is, I think, pretty bedrock in a lot of different aspects of psychology now. Um, it's like even taken for granted. Um, so yeah, Skinner, hugely important. And then I'm just going to end here with Jack Michael, who I would consider the actual like founder of ABA specifically. So if we go back, our Dr. Skinner was the founder of like the experimental analysis of behavior. Um, Jack Michael, I would say, is the founder of ABA. So he took a lot of those principles, like I said earlier, that were derived from EAB, and he brought them to humans. Um, he worked, I believe, in psychiatric hospitals, working with patients with psychotic disorders and intellectual disabilities. He also founded the Journal of Applied Behavior Analysis. Um, it really is really a lot of the foundational work. A lot of ABA, it got its foundation from working in psychiatric hospitals, like in a clinical setting, especially with patients that had previously been considered like unhelpable or unreachable, like especially with, for example, psychotic disorders. Obviously antipsychotics generation 1 and 2 were game changers, but a lot of these people would still have, weird, difficult, dangerous behaviors. And it was really ABA that showed these can be changed, these can be helped. Likewise with people with intellectual disability. Historically, they were really written off. Like in the 40s, 50s, if you had a child with a developmental disability, they were pretty much just taken from you and thrown in an institution, and it was just kind of assumed they weren't able to learn. There really wasn't much you could do to help them. ABA, especially Dr. Michael, really he really changed that. We could go on forever on just the history of ABA. Um, Just other important figures. So Ogden Lindsley, one of Skinner's graduate students, he actually founded the first human operant lab. So just like how Skinner was doing operant research with rats and pigeons and whatever, Lindsley began doing this work with humans. Additionally, he began the precision teaching movement that was really produced some really incredible results of um, education. A lot of precision teachers now are some of the best educators in the country. They also started the standard acceleration chart and the standardization movement. That's a whole other topic, but Lindsley is a hugely influential figure. Siegfried Engelmann, um, from project follow through and direct instruction. So these were really applications of behavior analysis to general education settings. I would highly recommend you look up project follow through. It is kind of incredible, and it's kind of a tragedy in our nation that we really that research isn't more talked about. And then direct instruction, and also what Engelman was really big on was what's called instructional design, of how do you take different lessons and how do you teach it in the most efficient manner possible. Prior to Engelman and really after him, because unfortunately a lot of his ideas really weren't adopted by the educational establishment, teaching and educating was really and is viewed more as like not a science or something to improve, but as an art, and that just relies on the skill of the teacher. Now remember earlier I talked about like technologies of behavior change. Really, direct instruction is an application of technology of behavior change towards education, with some pretty incredible, amazing results. Uh, Ivar Lovas, um, he was at the Young Autism Project at UCLA. Many people are only familiar with ABA through autism. A lot of those interventions came from him. You know, I think he can be a controversial figure, but I think we have, autism was seen for a very long time as a completely intractable, hopeless condition that there was really nothing you could do about. And Lovas, I think, really showed that that is not true, that autistic people can be educated, no matter how difficult it might seem or how problematic or difficult. Yeah, a pretty big name in the field. Stephen Hayes, now we're getting in more modern, um, developing relational frame theory and then ACT or acceptance and commitment there, training therapy, I guess, depending on your field, right? Kind of more modern stuff. And then Israel Golddiamond with nonlinear contingency analysis. Golddiamond himself worked with a lot of what we would consider more classic psychology. He treated individuals with things like depression or whatever, but also more severe things like psychosis. Um, and he did a lot of work that we still use today. Although a lot of behaviorists might not know any of these names. So again, all incredible people. If you're interested in learning more, I would look up all of them. So earlier I kind of referenced some basic laboratory finding like lawful relations um, that have been yielded through the experimental analysis of behavior. And I just want to kind of mention them here, um, because these are, I would say, like equivalent to laws of physics, just in that how important they are to our understanding of human behavior. So we have reinforcement. That just means a stimulus change that causes an increase in the future probability of behavior. Punishment is a stimulus change that causes a decrease in the future probability of behavior. And then extinction. A behavior no longer produces a desired outcome and eventually ends. So as far as we can tell, these seem to be about as universal principles as we can see in psychology. We've demonstrated them not only in humans, but in various species of animals of all sorts of different complexity, from very, advanced animals like, apes and elephants and pigs or whatever, to very simple animals. I think that they've even done conditioning experiments with like roundworms, like animals that barely have a brain to begin with. Um, and everything in between. I've seen people do operant research with fish, with turtles, with hermit crabs. Whatever you can think, there's probably been some sort of operant research done with them. Um, and that these principles are extremely replicable, and they've been replicated literally millions of times. I a lot across time and space. So, the same experiments that they were doing with that B.F. Skinner was doing in the 50s, you can replicate them today, that they're just so enduring and so powerful, which I think in psychology is a really rare thing. We rarely have such strong lawful relationships. Um, and from these lawful relationships and behavior, we're able, again, to derive those technologies. And that's super important. I've been saying this over and over. Um, we we have to have like things that are kind of constant, right? Those laws, the principles of behavior are what kind of give us that. Um, we try and create a natural science of behavior, and with all other natural sciences, we want to create usable technologies to improve people's lives, which is kind of what comes from, these basic principles. And then this also creates an opportunity for wide applicability. Like I said earlier, if you're familiar with ABA at all, it's probably in pediatric autism, but ABA really is helpful to literally anyone who's alive, um, right? We'll talk about more uses, but because these principles are so widespread, they that really opens up a lot of avenues for different research and applications. All right. So I've been mentioning this before, and I'm going to talk about single case research design because this is another like kind of unique and important aspect of behavior analysis. Um, This is sometimes called the control prediction model. So the basic logic of single case research design is that the individual acts as its own control, and that through careful measurement and manipulation of variables in a systematic environment and controlled way, we can see clear functional relationships between the environment and behavior. Um, some aspects of this is that generally single case research functions as a function of visual analysis. So if we can see the effect size, if it's observable, there's probably a functional relationship there. Um, and then we have different strategies for demonstrating experimental control. Um, Adding withdrawing, so we have withdrawals. So we add or withdraw different conditions to create within the experiment replications, and then behavior responding to these condition changes helps us establish that we have actually created control over the behavior we're interested in. Okay, multiple baseline designs. So multiple baselines are taken across different either participants, settings, or behaviors, and the treatments are introduced systematically. And then each baseline of the previous, whatever it is, behavior, participant, or setting, act as a control. So we can kind of see that it is the introduction of whatever the treatment we're doing, whatever our experiment it is, that is responsible for the behavior change. And again, this has within treatment replication. It's replicated at least 3 times, potentially more, although generally not more than 3 or 4 times. Um, Alternating treatments. So we cycle treatments very rapidly, and we should see if those treatments do have experimental control comporting of the behavior to different treatments, or it should change depending what treatment is given. And then the final one is changing criterion design. So as we set different criteria for reinforcement, we should, if we have an effective treatment, if we have a powerful program, we should see the behavior of the learner comport to those schedules, like at will, basically. Um, so I have some examples. And these are just pulled from just some random research papers I looked at that I have sitting in my um, drive. So we don't really need to know necessarily what's happening, but I just want you to kind of see how we can kind of establish a functional relationship. So in this set, we have, it looks like 6 sessions. We have a set of, I think the black dots are problem behavior and the white dots are requests. They have yep, that's exactly what it is. So in baseline, without any sort of treatment, we see that there's quite a bit, and this is responses per minute of problem behavior. They implement their first treatment, we see immediately a decrease in problem behavior and then an increase in requesting behavior. They add another, they withdraw the treatment, and we see immediately a reversal. So this is a good example of experimental control, right? That they are able to manipulate how the learner responds, I guess Mr. George, with changing the treatment. They reintroduce it, they see a reemergence of the behavior, and then we have generalization here. So, a month follow-up. with the teacher as the therapist. They have like eliminated the problem behavior, and they have more requesting occurring per minute. So that's a pretty classic, clean example. Um, Here's another learner, Clark, but we really see the same thing, right? So this Mr. Clark looks like he has a little bit more of a ability to respond, but prior to in our treatment, we see there is quite a high rate of problem behavior, not as much requesting as we want. We initiate our treatment and we see a clear bifurcation of the data. This quickly goes within what, 5 sessions to 0. Um, and then we get our thing here. They withdraw the treatment, and we see a rapid increase in problem behavior and a rapid fall off of our desired behavior. And we reintroduce it. We see it again, and then we see we have maintenance. And there we go. So that's a really classic example. Um, in this case, we have two replications, but in each case, we'd see we have our specific learner, our single case, and there's replication within the experiment. This is a really fun paper. So this is with cats. They're working on reducing aggression with cats. Um, so each of our little girls, Moxie, Winnie, and Chloe, they have their baseline levels of aggression. They introduce a treatment, and we see overall with all of them a fall off in behavior. They withdraw the treatment. We see the aggression returns. They then they re-implement the procedure, and then they work on fading it and extending it. So again, really classic experiments or what they should look like in behavior analysis, where we see visually, we can see there's clear changes in behavior, and those changes in behavior seem to very closely track onto our strategies of behavior change we're doing, right? We have, and here's an example of a multiple baseline across participants. So I believe this is for a paper on, this is a paper on toilet training. And we're actually going to look at a couple of graphs for these. Um, so baseline, these individuals were just not using the toilet, and then we implement our treatment, and we see a rapid rise in toilet use. Here we see this dude. It looks like he kind of went to the toilet sometimes, but then again we see as soon as we implement the treatment, we see a rapid increase in toilet usage. Same thing with here. So again, the multiple baseline logic is these clients, their behaviors, their toilet use isn't increasing naturally. It's increasing in response, excuse me, to the treatment. Right. So that helps us kind of determine that we're getting an effect here, that it's not just they randomly are starting to use the toilet by themselves, or that there's no other variable causing that. So this is from the same paper, figure 7. So this is an example of a client who really did need a lot more support. We're going to talk about a big strength of single case research design, but and one of them is that you are able to fix things. Like it's great. We had the previous things where we got really quick, fast, um, treatment effects. That's not always reality. Um, we talked about the analytic and the effective component at the beginning of the lecture. Well, here's an example. We did our baseline. Um, we did the treatment package, and it kind of worked. But this is toileting. You can't you can't toilet train someone to 80, 60, or 80%, right? Um, because they're still peeing their pants 20% of the time. It really needs to be like 100% of the time they're using the bathroom and the the toilet. So I believe they did a bunch of alterations. I don't think they say exactly what they were doing in this graphic, but we do see an increase in appropriate urinations, and I think in 1 month follow-up they weren't having any accidents. Same sort of deal. This guy Zeus, um, he was having some issues as well, so they required a little bit more time. All right, so the big advantage of single case research design is it is directly applicable to clinical settings and helps guide treatment. Um, so based on data, you can make quick decisions to alter treatment in the case of failure. Um, this is super important. Broadly, it's applicable to regular people as a tool. Um, so, when you can do little experiments with yourself at home. That's not like, going to necessarily yield like publishable results. But for example, when we talk about things like self-management or applying behavioral practices to yourself, you can kind of collect your own data and you can kind of test things and see how they affect yourself. The other nice thing too is that let's say you're a researcher, you know what I mean? You're working with maybe pigeons, that research strategy can be taken immediately from the laboratory to the clinic. This is a big problem with traditional psychology is clinical psychologists will receive a lot of training in group design or the statistical prediction model, and that's great and all. And the group design model has a lot of really great strengths. It's really good for answering a lot of questions, but it's not really useful when you're working with like a single person in front of you, right? Um, are we having mic problems? Do I have to say the magic words? Okay, yeah, sorry everyone. My microphone sucks. What was I saying? Yeah. It's just that single case research design is allows you to more quickly adjust your treatments. Another important aspect, and we've kind of seen in the examples we just looked at, is there is within experiment replication, which helps reduce the chance of false positives. We're probably all familiar with the replication crisis, especially in social psychology. Um, a big thing within behavior analysis is if you can't even replicate within your own experiment, you generally don't have a strong effect. It's not like worth publishing, right? Um, I think that's kind of helped protect behavior analysis specifically from not having the same sort of crisis that has affected social psychology. Um, you're able to demonstrate experimental control over behavior, um, which is super important. I think it allows you to have stronger foundation that your treatment is actually working, um, that it's not the result of like some third unknown variable. If you can demonstrate again that based on your treatment, you are able to manipulate the behavior at will, that's stronger evidence that what you're doing is actually the causal variable. Um, and then lastly, it's harder to manipulate data unless you're literally just making your data up. Generally, you can't fudge it in ABA. Um, not that it's not possible, but it seems to be a bigger issue with group design where um, they are manipulating, statistical information. The single case case design model does have weaknesses. It to have true like generalizable results, you do need a very high level of experimental control, and depending on the phenomenon you're trying to research, that's just not always possible. Even within behavior analysis, you can get perfect experimental control over um, a rat in a box. It's almost impossible to do with like an autistic child or an adult or whatever. Um, Results of single case research design can be generalizable as long as you can replicate that across not just one experiment. One single case research design, even if it has a really good effect, isn't necessarily strong evidence. But if you take that same procedure and you replicate it across like 4, 5, 6 experiments, and you're consistently showing that this procedure does produce, outcomes, that is, I think, strong evidence that can be generalized. Um, and then lastly, visual analysis, like in the papers we saw, those are pretty clear, I think, examples of pretty clear examples of effect sizes that are pretty strong. But there are more edge cases or places where it's not really clear, especially in the real world where you don't have strong experimental control. And visual analysis, when it gets to those smaller things, can be honestly a coin flip. It is a serious problem with the field that sometimes with those edge cases, it's not quite clear if you are getting an effect or not. Although some would say if it's not quite clear, it's not an effect at all. But it is a weakness. ABA does use group designs in some areas, but it is less common throughout the field. Group designs are definitely better suited for some questions, especially population level. Um, they they do require less precise control over conditions. Obviously, the more control, the better. But a big part of, the statistical prediction model or group design is that by adding more participants, you kind of smooth out all those little variables that you can't control, right? And it gives you maybe more generalizable and more clear in some cases finding. Statistical prediction can also disentangle kind of the level at which different variables are potentially affecting outcomes. So they're both useful. Um, I often find that, unfortunately, we only teach the group design or the statistical prediction model, at least in psychology. I don't know about biology as much. Um, but just to say that single case research design does have a lot of uses, um, and that I do think it is another strategy of science with its own strengths and weaknesses. And it is useful in some cases for answering some questions, especially in the clinical world. And then lastly, we're coming up on an hour. I do just want to kind of end on where is ABA used? You know, um, it's most famous, again, as I've said multiple times, in pediatric autism. And in fact, the term ABA is often synonymous with autism therapy. But that's not really the case. It is a full science with many different applications. Um, so I do want to start off with saying um, early intensive behavioral intervention. So the application of ABA to children with developmental disabilities, usually autism, but not always. Just, in my practice, especially when I worked in the clinic, is I work with children with autism, ADHD, Down syndrome, uh, ADHD, just general intellectual disability. I'm trying to think of more. As a working with adult, I work with a gentleman with Cornelia Lang syndrome. Um, whatever it is, we're not really concerned necessarily about diagnosis. We are concerned more about behavior. Working with animals. So behavior analysts do work in zoos. Um, they do treat problem behaviors that do occur with animals in zoos. Um, I lost this paper, but I read it was this really fascinating paper about the functional analysis. Like animals will do weird behaviors in zoos. They'll like do stereotypies, so like kind of weird repetitive behaviors. They might stop eating when there's no clear medical cause. They might do things like pulling fur out, or like birds like pulling their feathers out, and the the reason might be behavioral. So behavior analysts work in those settings. They also work in doing animal training. So, for example, teaching animals to accept blood draws, teaching animals to accept toothbrushing. Yes, I think zoocytosis. I think that's literally what they're. We call it zoocytosis, but it's not psychosis in what we would consider. It's that the animals are doing bizarre behaviors, and they try and find the reason why, the behavioral reason why, and treat it. Education. So I mentioned earlier that ABA, like indirect instruction, is used in teaching material and in teaching instructional techniques. Additionally, it's often used in schools to remediate behavior problems, to help children access, typical learning environments. It's used in drug addiction quite a bit. Um, there's a whole field called contingency management, which is the application of behavioral principles to assisting in the remediation of drug use, including like quitting cigarettes, working on reducing the use of more intense drugs like meth or cocaine or whatever. Um, at PsychDev, we actually read a whole journal series on behavior analysts working specifically in the addiction world. And again, interestingly, in that field, they do primarily do group statistic design. Um, Used in mental health treatment. Um, so there's a whole field called clinical behavior analysis where they're working on applying principles of behavior to treating mental health issues. Less familiar with that world. I know there are different areas like functional analytic psychotherapy. We might consider ACT as part of clinical behavior analysis. Um, Working in weight loss. There is a gentleman, Dr. Green, with Behavior Fit. He works primarily in using behavior analysis to work on helping people increase their weight, or excuse me, decrease their weight. Gerontology, yeah, we'll get there. Um, Sports and fitness training. Um, I know there's an outfit called, I know it's run by Kirk Kirby. What is it, their thing called? Let's look it up real quick. Kirk Kirby. Team ABA. So they are a sports training outfit. They work with athletes both in the professional world and in the um, the amateur world, and they work on training athletes using behavioral technology, using single case research design, organizational behavior management. So applying principles of behavior to workplaces, working on increasing employee competencies and employee skills, working making sure you have proficient workers. Um, Behavioral gerontology. So working on working on old people issues. So more when we're talking about that, a lot of people with conditions of old age like Alzheimer's, dementia, also will frequently have like severe behavior problems. So behavior analysts are working on in those areas to try and remediate those behavior problems. They might also be working on like skill retention or working on improving their behaviors, like their functional behaviors, or increasing their engagement. General parenting. I've met a lot of behavior analysts who are doing things in like they'll do like actual as parent coaches for typical children. They'll work on improving those behaviors. And then I see someone mentioned self-management as well. So that's the application of principles of behavior analysis to yourself, to work on changing your own behaviors. Okay, so that's just a quick overview. I'm happy we got it in an hour. I do have some reading. If you are interested in learning a little bit more about behavior analysis, these are some pretty general, open books. The first two are very easy to read. They're very fun. Some of my favorite books ever, both by Karen Pryor, is Don't Shoot the Dog: The New Art of Teaching and Training, Reaching the Animal Mind, Clicker Trading and What It Teaches Us About Animals. Both really easy, simple books to read. They're a lot of fun. So self-directed behavior, so self-modification for personal adjustment. This is an actual textbook. I personally found it, but I'm a nerd, but very readable, very fun. And it's really like a step-by-step guide of how do you enact a self-management project? How do you apply principles of behavior to change your own behavior? Um, I think a really great book. I'd highly recommend it. Science and Human Behavior. Um, This is a classic in the field, written by B.F. Skinner, and it really kind of goes over a lot of the basic precepts of behavioral science. Uh, I will warn you. So the next three books are written by Skinner. He is not a very engaging writer, so his books can be a little difficult to read, unfortunately, but it does give you a pretty good overview of the science. Beyond Freedom and Dignity, really interesting book. Um, Really, Skinner lays out kind of the case for a technology of behavior and kind of why it's important and how it affects our own society, right? And then About Behaviorism is really just the whole debunking book. Every dumb thing you've ever heard about behavior analysis, and it literally hasn't changed in the past like 100 years. He kind of breaks it down about why it's dumb and kind of what the correct behavioral answer is. So great reading list. I recommend all these books, but if you're, yeah, he just has a really bizarre, stilted, uncomfortable writing style. Not pleasant.